next topic of discussion is something called proportional reasoning. All right, so what is proportional reasoning? Every once in a while, you run into a question where you are asked to solve for something, but it seems that you don't have enough information to be able to do it. However, there are times when you can actually rely on proportioning to take care of this problem. And in fact, some of the most important problems in physics in history have been solved without actually knowing all of the information necessary. And we're going to do an example. We're going to talk about something, use a formula called the force of gravity. So the universal gravitational equation, which is this one right here, which we're going to be talking about a little later in the course. This equation here helps us to determine the force of gravity between any two objects. Now, it is not at all important to know what any of these values are or how we got the equation, but I'm going to show you how we can manipulate it. So let me just do a little rundown. Fg refers to the force of gravity, and it's measured in units called newtons, obviously named after Sir Isaac Newton. Big G is something called the universal gravitational constant, and that number is 6.67 times 10 to the negative 11, but we don't even need to know that number. So let's say G is unknown to us. M1 refers to the mass of one of your objects measured in kilograms, and M2 is the mass of the other object, the second object measured in kilograms, and R represents the distance separating the centers of these objects. So that's your force, that's a constant, that's the mass of your first object, mass of your second object, and that's the separation distance between those objects. So let's take a look at our example. If the gravitational attraction between two bodies was 4 newtons, so that is your Fg. What would happen to the force if the mass of one body was tripled and the distance between them was cut in half? Okay, so you're expected to find out what the new force is. It's going to be different than the force 4 newtons, but you are not given what the individual masses of both objects are, how far apart they are originally, and you're not given the value for G. This seems like a question that you can't solve. It seems like we don't have enough information. The only number we've been really given was the original force. And what else we've been given is what happens to the mass of one object and what happens to the separation distance, but we don't have the original value. So this is how we go about it. We start off with our original equation. And so we're using the subscript 0. And the subscript 0 is actually the term that is often used is the word not. So you'll hear physicists will often say, F naught or V naught. Well, how do you get naught out of that? It's a 0. Why is it called 0? Well, it's not, or not, but not. Was that clear? Well, let me clarify. It's not the word not or not, but the word not. And this word not is an old school English way of saying 0 or our original condition. So there you go. A little etymology for you. So we start off with the equation. So with this equation, we have Fg naught. So the 0 stands for the original. I don't know what the G is. I don't know what the M1 is. I don't know what the M2, and I don't know what the R is, but I know all of these things combined in this way, that is equal to 4 newtons. Now, let's take a look at the next one. I'm going to use the new subscript N to represent new. So here's what we know. We know that one of the masses was tripled and the separation distance was cut in half. So those are the changes. So what I'm going to do is I am going to modify that equation. So I've got Fgn, the n meaning our new one. Now, if you notice, I've multiplied my first mass because it didn't specify which mass I'm going to hit. So I am working with the first mass. It doesn't matter. We could have done the second mass. So notice I put a bracket in here and I put a 3 in front of the M1. So I don't know what the original M1 is and I don't really care. I just know that the new M1 is 3 times that. Then let's take a look at R. Now the radius value, we know that it's cut in half. Again, I don't know what the original radius is, but I do know that it's half. Now this is very, 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 very important. And that is the brackets. You have to make sure you put the brackets in the right spot because it's R squared. And if you double R, that means you have to square all of it. So if you double R, you have to double the change as well. So that's why when you substitute in, you have to have your brackets there. So if R was 2, doubling R would be 4, and it would be 4 squared. Otherwise, if you don't do it this way, if you do 2 times 2 and then you square it, this is wrong because that's going to be 2 times 4, which gives you 8. But this is 16. So you have to make sure that you put that change, that times 2, inside. Now in our case, it wasn't times 2, it was cut in half. So we made sure that the half is inside the bracket. And then what we're going to do is we're going to apply the square on both of these things. So when you distribute the square, the 0.5 gets squared and the 3 gets squared. So we're left with 0.25 r squared. Now, the next thing what we're going to do is we're going to take these new numerical coefficients and we are going to bring them out front. So now here's the thing about math. The order in which you do multiplication does not matter. Let me give you an example. 1 times 2 times 3 is the same as 2 times 1 times 3, which is the same as 3 times 2 times 1. It does not matter the order in which we do multiplication. So I can take this 3 and bring it out front. Same thing with the denominator here. Now, the next thing, what I've done, and if you'll notice, is I've made a new fraction over here. And yeah, you can totally do that because that is the same as something like this. So let's say we have 2 times 4 over 3 times 5. You can rewrite that as 2 over 3 times 4 over 5, and it will give you the exact same result. It doesn't make a difference. So you'll get the exact same thing. So whether we do this or that, it should equal the same. Let's prove that. So we're going to start off with this one. So we're going to go bracket 2 times 4, close bracket, divided by, open bracket, 3 times 5, close bracket, equals. So we get 0.533 repeated. All right, let's clear that. So now let's do this. So now we're going to go 2 divided by 3 times 4 divided by 5. So bracket 2 divided by 3 times, I forgot to close my bracket. Let's try that again. Bracket 2 divided by 3, close bracket, times bracket 4 divided by 5, close bracket. And there you go. Exact same answer. All right, so back at the original question. So now what I've done is I've taken these new numerical coefficients that we got and I've put them in a separate fraction out front. So now, what does that do for us? It seems like we haven't got much further. Well, here's the thing. Take a look at this thing specifically. This G, this M1, this M2, and this R are the exact same as this G, this M1, M2, and R. And I know in this combination, G times M1 times M2 divided by R squared is equal to 4. So that means this G, this M1, this M2, and this R squared in this combination also equals 4. So, and that's what I'm argued down here. So again, this is the same as this, and that's equal to 4. So I can replace G M1 M2 over R squared with 4, and boom, 3 over 0.25 times 4, there's our answer, 48 newtons. And the impressive thing is that we were able to come up with this answer with having a bare minimum of information, almost seeming like we didn't have enough. And it entirely was possible due to this technique of proportional reasoning, which I sometimes will refer to as pretty blue box because of the little blue box I put in there. And the reason why is because when I talk with students, if I say something like proportional reasoning, they'll look at me as if I have 6 heads. But if I said, remember the pretty blue box thing, and then for some stupid reason, people remember that. So I use that ridiculous term, pretty blue box. But proportional reasoning is the more professional, technical way of describing it. So that's it for this. The next video, I think we're going to do some problem solving involving these techniques. So we're going to do some more questions, some more sample problems on the website. I'll actually post the original questions. And then I will go through and do the solutions of those questions that involve both sine law, cosine law, and this proportional reasoning.